31. So manual calculation, what I did like that, you have to do the manual calculation. Copy the manual calculation in your notebook. Okay. This is for this FB value. When you provide your data, you give your serial numbers. Okay. According to your serial number, you give. Let us go to the program. First step, origin 000. This is origin of the program. Next, the data we are giving is FB. So your data means you load your values, your registration number or serial number, whatever you are going to consider. After that, what I am going to do is I am going to have a pointer R0 to 40H. Why is R 40H? Because in the program they are given the RAM location. The results has to be stored in 40H. Okay, so I am giving 40H. After that, what I am going to do is I am going to load a 10 in B. It is equivalent to 0A in hexadecimal. Either you can load a 10 in B or you can give instead of this 0A in hexadecimal. Okay. After that, you are going to divide. The instruction used for dividing is divide div AB. So what you will get, quotient and remainder you will get. So you are going to exchange this because the remainder will be in B register. So I am temporarily moving the B register to A. So quotient and remainder I am swapping. After that, as I said manually, I have to add 30 with it. Add 30 because this will give my decimal number. The decimal number added with 30, I will get the ASCII equivalent. Okay. So this has to be repeated for the next iteration. Therefore, I am copying the resultant value to the memory location 40H. As well as I am moving that to the port 1 to lively checking the output. After that, again I am exchanging the quotient and remainder. Okay. So because again I have to divide the quotient by 10. Okay. Increment this step and check till it becomes 0. Okay. When it becomes 0, I am stopping the output. When the quotient becomes 0, I am stopping the output. Okay. So end program. So let us run this program to understand visually. So I am removing this program, adding the existing file T3 2. The same program. I am checking for errors, no errors, building the target, start simulation. The output will be in P0. Remaining ports you can switch off. Only this port is sufficient. Observe here, line by line execution. First R0 is configured to 40H, pointer. Okay. Next B is configured to 0A and A is loaded with a value. Here I am loading a different value, FF. Okay. So FF has been loaded 0A. Next I am dividing FF by 10. What will be my quotient? 19, remainder will be 1. Okay, hexadecimal values. Remainder will be 5. Okay. So remainder will be in B register. You can note down, remainder will be in B register, quotient will be in A register for division. Okay, next step, you can observe that this value is going to be swapped and then 30 is been added to it, 35. So now you observe here in the memory window, you can see that the first answer 35 is been obtained. Same time, if you click once, you can it is in port 1. So close this, view, peripherals, port 1. You can see that peripherals. Okay. So we can observe here as well as next iteration it will go. Again we are going to increment the pointer to 41. Divide that value 19 by 10. Okay, that is B becomes 0A. I am dividing the quotient 02 and 05 is the remainder. Swapping that adding 30 with it, so 35 will be the answer. You can observe here 35 extra, okay, and you can observe here also 35 will be there next iteration, okay. Now pointer has been pointed out to next location 42. Again I am dividing, the quotient is 0a has been divided by 10. Now the value will be, accumulator will be 0, remainder will be 2, okay. Next iteration, adding 30 with it, the accumulator becomes 32. Now I am moving that to or not, I am moving that to port. You can observe here this port, 32 is here, 32 is here, both the cases. Now you can see that changing the operation, accumulator becomes 0. If accumulator is becoming 0, this 0 condition will be satisfied. Incrementing R0 to the next location, 0 condition is satisfied, it will come out of the loop. So the program is done. Everyone understood? Good luck.